Hello, ladies and gentlemen. Welcome to Math 30-2, Chapter 3 Review, Part 1. So, Cassie and Jacob are playing a game. 6 tiles, numbered 1 to 6, are placed face down. Each player selects a tile. If the sum of their 2 tiles is even, Jacob wins. If the sum is odd, Cassie wins. Is this game fair? And explain. Well, first things first, what do we mean by a fair game? Fair game means that each player has an equal chance of winning, or an equal probability of winning. It doesn't have to be 50-50, as long as each of them has an equal chance of winning. Now, this one is a little confusing, because there's 6 tiles, numbered 1 to 6, are placed face down. So, let's look at our possible outcomes here. Each player selects a tile. So, here, I think the easiest thing is to actually list them. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Now we've already got 2, 1, so we can't have 2, 2, so it's 2, 3, 2, 4, 2, 5, 2, 6. Or the first tile is a 3. One of the tiles is a 3. We've already done 3, 2, 3, 1, so we can't have 3, 3, 3, 4. 3, 5, 3, 6. You see the pattern here. So, 4, 1 has been chosen, 4, 2, 4, 3, we don't have 4, 4, so 4, 5, 4, 6, and then it's 5, 6, and we're done. So, I don't like listing them all, but it's the only way I can see. So, if the sums of 2 tiles are even, so, Jacob wins if the sum is even. So, even, 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 even. Yes. Now, odd, Cassie wins. So, Cassie will win 1, 2, 3, 4, 5, 6, 7, 8, 9. So is this game fair? No. Cassie wins more often. Cassie will win in theoretical probability 9 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 9 out of 15 times. Jacob will only win 6 out of 15 times. So fair games, they both won the same percentage of the time or same probability. They're both 6 out of 15 or 7 out of 15. But they're not equal, so it's not fair. Now, the odds in favor of an Inuit person being able to converse in more than one Aboriginal language are 7 to 3. Determine the probability that an Inuit person can converse in at least 2 Aboriginal languages. Now, odds in favor are what you want versus what you don't want. So probability, what you want, that is speaking 2 languages. These 2 languages is 7. Out of the total, 7 plus 3, or 7, 10, which is 7, or 70%. Okay? So also kind of modifies to make it look nice. Okay, so 70% chance you can speak it, converse at least 2 Aboriginal languages. Odds and probability. So, a credit card company randomly generates a temporary 3-digit passcode for cardholders. Braydon is expecting his credit card to arrive in the mail. Determine the probability this passcode is made up of 3 different even digits. All right. So, how many different even digits are there? Well, there's 2, 4, 6, 8. So there's 5 digits. So he has 5 choices for the first. Since 1 is used, 4, and then down to 3. That is 60. Now, how many possible passcodes are there? Well, you realize it's 10 choices, 10 choices, 10 choices. because as far as we know, there's no restrictions. So that's 1,000. So that probability even is 0.06 or 6% chance. It's 3 different even digits. Okay. Now, in the card game called Crazy Eights, players are dealt 8 cards from a standard deck of 52 playing cards. Determine the probability that a hand will consist of 4 hearts and 4 spades. Okay. So, probability 4 hearts, 4 spades. Well, 4 hearts, that's 13 hearts, randomly choosing 4. 4 spades, it's 13 spades, randomly choosing 4. And note that there are 52 cards, randomly choosing 8. So to do this, I'm going to pull out Mr. Calculator, and I should be on the board here. There we go. So 13C4. So if you want to get picky, this is 715 times 715 divided by and 52C8. Boom. 752538815. Now, turn that into percentage. That is 715 times 715 divided by, which is 6.79 times 4. Very small chance, 4 hearts and 4 spades. Because there's a lot of cards you're pulling out. Okay? Now, Katie plays the balloon pop game at a carnival. There are 50 balloons, with the name of the prize inside each balloon. The prizes are 10 stuffed bears, 4 toy trucks, 20 stuffed rabbits, 6 yo-yos, and 10 giant stuffed cats. Kaylee pops a balloon with a dart. Determine the probability that she'll win either a toy truck or a yo-yo. Well, 4 toy trucks, and how many yo-yos? 6 yo-yos. So probability of a toy truck or yo-yo is 4 toy trucks and 6 out of a possible 50, which is 10 out of 50, 0.2 or 20%. Okay, so there's a 20% chance she'll get a toy truck or a yo-yo. Hands tosses a coin and then draws a card from a stacked deck of 52 playing cards. Determine the probability you toss a head and draw an 8. Well, I like setting up a tree for this. You don't have to, but. Okay, so he tosses a coin. He'll probably toss a head. Okay, also, sorry. In class, I'm talking about heads and not heads. So that's 1 in 2 chance of getting a head and toss and draw an 8. 8, not 8. Now, there are 4 8s in the deck of 52. So, probability. Now, to get fancy, I should be saying probability of head and 8. Probability of getting a head times probability of getting 8. Is that and together or no? Intersect, yes. So this is 1/2 times 4 to 52, which is 13. So that's 1 in 26. And I can't do that math in my head. 31 divided by 6. 2.3. 28% chance of getting a head and drawing an 8. I figured I wouldn't bet on that. Now, I'm going to stop here. I want you guys to review these and then continue on with the next set of questions, okay? Good luck.